Hello everybody, this is video 7.4. We're going to be looking at proportional relationships and particularly solving some examples around proportional relationships as well as sort of how they exist in comparison to inversely proportional relationships, which is video 7.5. So 7.4 and 7.5 are kind of two sides of the same coin. A lot of what we're going to be doing in 7.4 will make more sense after 7.5, so after you've seen them in comparison. But we're going to go through the same ideas in both videos. It's going to use the same sort of structure, so the comparison is a little bit more obvious, makes a little bit more sense. So let's get started. So we have an example here, an example problem, and what I'm going to do is I'm going to work through this example problem uh, and show three different characteristics of what's going on in this problem. So the solution obviously won't change, and a lot of the work won't change, but in each of these solutions, I really want to focus on sort of one characteristic of this proportional relationship. And so the problem says 7 gallons of petrol diesel are sold at a gas station. For every 7 gallons, 3 gallons of biodiesel are also sold. If 7 gallons of biodiesel were sold, how many gallons of petrodiesel were also sold? So we can use a ratio table to solve this problem. So we saw this earlier in the chapter. So we've got our petrodiesel, we've got our biodiesel. We'll extend this out. And for every 7 of petrodiesel, there's 3 of biodiesel. And so we can double this and make this 6 and 14, double this again, make this 12 and 28. So we're using our doubling strategies from earlier. And now if I add these two together, this makes 18 and this makes 42. And then if I add the 3 onto that, I get the 21 that I'm looking for, which means I also need to add the 7, which makes the 49 that I need. Okay, so this is one solution using this ratio table. Now, the first characteristic that I want to point out is notice that as biodiesel increases, so does petrodiesel. Okay, this is an important characteristic of proportional relationships, is that they move in the quote unquote same direction. If I started off by saying 49 gallons of petrodiesel were sold, 21 of biodiesel, and then worked the other way, then as the 49 would decrease to the 7, the 21 would decrease to the 3. This is the case for all problems of this type, for all proportional relationship problems. As one variable increases, the other variable increases. If one variable decreases, the other variable decreases. There's not going to be a case for a proportional relationship problem where one increases and the other decreases. Um, they are going to move in the same direction, um, assuming everything is in positive numbers, that we're dealing with positive quantities, and we're dealing with quantities of things. So we're not gonna sell negative 7 gallons of petrodiesel. So we're typically talking about these things in positive numbers. So this is the first characteristic to remember, that they move in the same direction. Now for our second characteristic, you can see I've kept some of the data from the previous slide here. So what we're going to do is we're going to draw this out, and we haven't done a lot of graph drawing in this class, but I'm going to put P on this axis and B on this axis. As you might imagine, this might not be for every student. I think graphing this out in a very intuitive way certainly could work. How rigorous you want to be with some of the definitions, if you want to talk about X and Y axes or not, may or may not sort of conflate what you're trying to do here. So we can label this point 7, 3. We can label this point 14 and 6. And then this point up here we'll label 28 and 12. Right. And so you can probably figure out this point here would be 21 and 9, which is not in the data set. But this is the point, that all of these points fall on this line. Not this line, that one's kind of wonky, but this line. And you'll see sort of as an extension of this, well, what if the gas station didn't sell any petrodiesel? Then how many gallons of biodiesel would they sell? Well, zero. For every seven, they sell three. So if they don't sell any, then they don't sell any of the other one either. And so this is characteristic two, that proportional relationships always form a straight line. They're always linear. Now, this is probably further than we need to go, but some of you will probably recognize this is 3, this is 7, and so we have this slope of 3/7. So some of you might remember this as your change in y over your change in x. Some of you may remember this as rise over run. If you've had, 138 or 114 or whatever, math class, or maybe, you just remember this from high school. This forms a linear relationship. We can define the slope of this, and the slope we can get from this ratio. So there's a definite connection here between this ratio, this simplified ratio, and this slope. We're not going to talk about that anymore in this class. I just want to point out that this is the case. For what we're concerned about is for this class, is just that you know that it forms a straight line. The characteristics of that line are not essential to this class, but I would say they are essential to being a good math teacher. So this is relationship two, that they form a straight line. Characteristic three, and I tried to go in order of sort of difficulty and sophistication here. The first one was that they move in the same direction. The second one is that they form a certain picture. The third one is a very abstract and very symbolic relationship, and that is that these things, that this ratio forms a constant quotient. And we'll sometimes hear this referred to as a proportionality constant. And so we have an equation here. We could say that we've got 7p is to 3b. And so if we found a unit rate, we could say that 1p equals 3/7 b. So for every p, it would be 3/7 of a b. So if we continue this on, we could say that 2p is 6/7 b, that 3p would be 9/7 b. And so you can see here that b is going to be the amount of p times 3/7. Fix this 7 here. The 7 is going kind of sideways on me here. So if you look here, so if p is 1, 3/7 times 1 makes 3/7, so that's how many b we have. If p is 2, then we put the 2 in for p, so 2 times 3/7 makes 6/7, that's how many b we have. Now, this is why I'm doing this one third, because it's, like I said, the most abstract and the most sophisticated. It's also the most generalizable. So now, if I given any p, I know the multiplication by which I can find the b amount as well. But it's a little tricky, because if you look at this here, this is as a ratio. I have 1p is to 3/7 b, but my equation is b equals p times 3/7. So in a way, it kind of looks like, quote unquote, the 3/7 in the wrong place one way or the other. The 3/7 is with the b here, it's with the p here. The distinction is that the 3/7 here is an actual, it's an amount, it's a quantity. And here, it's a multiplicative scale factor. So the 3/7 are being used for different things in the two forms of what's being expressed. So if they're being used differently, then we shouldn't expect them to be in the same place or do the same thing. So this takes a little bit of work on the part of the student, and maybe on the part of the teacher, to really make sense of what's going on here. We can do the same thing. This is a colon, not an equal sign. So we could say 3p is to 3b. And so now if we divide by 3, I get, for every one biodiesel, there were 7/3 petrodiesel sold. And I can go through and look at some more examples of this. So there was 14/3. And this is also weird because we have a fraction inside my ratio, And so this fraction is going to behave a certain way, and the ratio is going to behave a different way, which we've already sort of talked about. I don't need to do 3b because it's right there. 4b, I can see is going to be 28 thirds. And so now I have my relationship now that the amount of p is going to be the b amount times 7 thirds. Now, for those of you proficient in algebra, you know this makes sense. Because if I move this 3/7 to the other side, if I move it over here, I do that by multiplying by the reciprocal 7 thirds, so I expect it to change from 3/7 to 7 thirds. This is the most generalizable, like I said, but this is also the most abstract. This takes a certain amount of work. Everyone should understand characteristic 1. Most of you should understand characteristic 2. I would like for all of you to follow characteristic 3, but it's a little algebra heavy, so it may not be for everybody. But if you don't quite get it, then set that as a goal for you to understand this third characteristic and how to use this equation form to solve problems around proportionalities. So, for your checkpoint, we have a problem here. At a store, for every 2 radios sold, they also sell 7 televisions. If they sell 12 radios in a month, how many televisions did they sell? So, solving the problem, probably not that complex. I'm sure everybody can get to the answer. I want you to think about, though, how to use characteristics 1, 2, 3 to talk about, to explain this problem, right? So I don't care about the 42 as much as how you're able to use those characteristics to show the 42 and how those characteristics work with that 42. So the answer kind of secondary to the work that supports that answer. As always, if you have any questions, please be sure to let me know. Thank you.